we've got some numbers here. We've got we've got some children at a nursery. They're either going to be boys or girls, and then some of these boys are going to arrive by car, and some of the girls are going to arrive by car. And we want to know the probability that a child chosen at random arrives by car. Well, the probability bit gives it away a little bit. A really good idea for this sort of question is to draw a tree diagram to start with. So we've got boys or girls. 40% of boys, that's as a decimal is 0.4. I quite like to write it as a decimal, just get rid of that percentage. And that's going to mean that 0.6 or 60% are girls. Then if I just look at the boys for one moment, they're either arriving by car or not arriving by car. We've got 70% arriving by car, that's 0.7. So not arriving by car is 0.3. Girls, and then 60% arriving by car, and therefore 40% or 0.4 going to be not arriving by car. And we want to know the probability that a child chosen at random from the nursery arrives by car. So it's either a boy and arrives by car, or we pick a girl who arrives by car. And for this, we multiply along the tree diagram. I hope it makes sense. When you look at the percentages, it makes a bit more sense. If I take 40%, and then I take 70% of those, then I need to multiply those two things together. It's like if I have 1/10 of something, and then of that, half of it, then you're going to do 1/10 times a half. It's the same kind of idea with fractions. Decimals, they're equivalent to a fraction. So we're going to do 0.4 times 0.7, that's 0.28. And 0.6 times 0.6, that's equal to 0.36. I could work out the other ones, and sometimes when I teach it, I say, yeah, just find them all. But I'm not going to do that here. I'm not actually interested in those that don't arrive by car. What I'm interested in is these two numbers, but it could be either these or these, so I need to add them up. 0.28 plus 0.36, and that is equal to 0.64, or 64% of the children arrived by car. Probability is therefore 64% or 0.64.